Okay, section 1 of the review. You actually don't have to factor anything if you read the directions. It just says to name which method you would use based on how the problem looks. As I go through naming these, I'm actually not going to do them in numerical order. I'm going to do them sort of just based off of my own opinion of what's the easiest to recognize, because it's my video and I can do whatever I want. So in my opinion, the easiest one to identify is grouping. Any grouping question is going to have 4 terms. So that should be pretty easy to identify. So looking over these problems, it looks like number 4 is grouping. In my opinion, the next easiest one is going to be the simple ABC. So in a simple ABC, it has to have 3 terms, and the first term has to be has to have a 1 as the coefficient. So the number in front has to be a 1. So that makes number 2 a simple ABC. And number 7 is also a simple ABC. Let's see what else we got here. We have a complex ABC. Complex ABC also has 3 terms. But the thing that's unique about complex is the number in front of the A term. So basically in front of your x squared, that's your A. It's not a 1. So it's basically any other number besides a 1, and it's also not the GCF. So it looks like problem 1 is a complex ABC. And that's the last one that has 3 terms, so we're done with those. The next ones that stand out to me are the binomials. So we have 2 different types. We have difference of squares, and we have sum and difference of cubes. So the difference of squares, I'll go ahead and talk about that one next. The difference of squares, it has 2 terms. So looking at what's left on this worksheet, they all have 2 terms. So I need to give you some more instructions. The reason why it's called a difference of squares is because it has to have a minus in it. Number 3 has it, number 5 has it, and number 6 has it. But in order to be a difference of squares, each term has to be a perfect square. So that basically means you have to be able to square root the stuff that's in there, each term separately. So if you go to number 3 and you try to square root 9, it actually doesn't work. You can't square root it because it's odd for the exponent. If you go into number 5 and try to square root the 34, that's a decimal, so that doesn't work either. If you go to number 6 and you square root the 36, that actually does have an answer. And if you square root the 25x squared, that also has an answer. Notice I didn't put the minus. We don't really square root minuses in this class yet. Later on, we'll figure out how to work with those, but for right now, we don't. So that has 2 terms. It's got the minus, and both terms can be square rooted. So that means that this one is difference of squares. Okay, so now the next thing may be cubes. This doesn't look like the other ones are going to work. Number 8 is not going to work because, again, it's x to the 3rd, and that's odd, so I can't square root that. I can't square root 27 either. So we've got sum and difference of cubes. Sum and difference of cubes will also have 2 terms. This one could have a plus or a minus in the middle. But the way we're really going to be able to tell is we are going to hopefully be able to use a cube root. Now, a cube root is different from a square root. It's a totally different button on the calculator. So we can go through and try to cube root our stuff, and if it works, it's probably that one. So I'm going to start off with number 3. If I cube root x to the 9th, that's x to the 3rd, because with exponents, all you do is divide it with the index. So 9 divided by 3 is 3. That works. Cube root of 64 is 4. So both of those actually work. So it's got 2 terms. It's got the minus in the middle, and the cube root works. So that means this one is a difference of cubes since it's a minus. I got another one over here, number 8. Number 8 looks like I can cube root the first term. That's just x. I can cube root the second term. That's 27. Actually, it's 3. And so it works. 2 terms with the plus sign. Cube roots work. So this one is going to be, this time, a sum of cubes. Looks like the last one, just by process of elimination, is going to end up being GCF because square root doesn't work, cube root doesn't work. So it looks like this one is going to be our GCF. So it looks like we could probably divide both of them by 2x squared. So hopefully, just by hearing my strategy and how I think out loud, it'll help you do better on your test when you have to name what type of process you would use to factor these things. The last question in this section is find the error in the factorization of the following expression and then factor it correctly. So we're going to just kind of take a look at what they did here. This first thing I noticed right away, it's got 4 terms. Anytime we have 4 terms, we're going to do it by grouping. 1, 2, 3, 4. So there's our 4 terms. It looks like they pulled out a 3 as the GCF. It looks like they pulled out the 3 correctly. And then it looks like at this step, they start doing their factoring by grouping. So they took out an x to the 3rd from the first set of 2 terms and an x from the second set of 2 terms. So we've got our matching parentheses here and here, so they pull it out as x minus 3. They use this to come up with this parentheses here. So at first glance, it looks like they did it right, but the thing is, they actually didn't pull out as much as they could have in the first step. Now, you don't have to redo the whole problem. If you don't take out the GCF correctly in the beginning, you can always catch it at the end. So if you just look at this parentheses here, you'll notice they both have x's. Anytime you have stuff that has letters all the way through it, you can usually take out letters. So in this one, we have a GCF that we missed in the beginning of x. So you can actually just pull it out at the end. So our correct answer should have been 3x, x squared plus 1, and x minus 3. So the error, they did not take out the GCF of x. And you can see it in the first step. It's got x, 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 x. If they all have it, you should be able to take it out.